we're going to start with. So complex numbers, unit 5. For those of you who go way back, can you remember what letter did we use to identify what a complex number was? I helped us identify like what it looked like. E, not E.
No E.
Not C. That's good though. That's in the complex read data. We call a number Z in the form of sum A plus BI. Kind of our root of complex numbers. Anybody remember what form that's called? Yeah, Cartesian form. So I'm going to try and use a different color here so we can see it. This is called your Cartesian form of a complex number. That's the number that we're familiar with. That's the number that helps us plot. That's the number that's the value that we can use for a whole lot of different things. Okay. We have another form of a complex number. And some of us know this because it's really fun to plot these, if you know how to plot them. But it's called trig form. Does anybody remember what trig form looks like?
Cosine.
Yeah, you need a cosine of theta. I heard cosine out there. What else do we need? Sine of theta. Now sine is unique because we need to add an I in front of it, because that's going to be our imaginary component for sine of theta. This whole slew of things is going to be called our trig form, trigonometric form. And then ultimately, we end up with another, which is called your polar form. Polar form looks like a point. It's not a point. It's almost like a series of coordinates that tell you the radius, length, and then how many degrees I'm spinning around. Okay. But there's three main forms that we discussed in Unit 5. Now, I'm going to say this again. You don't need to copy all of this down. Shannon's going ahead. She's recording it, so I'm going to upload it, and you can check it out later if you just want to listen and try and absorb some of the information. Okay. So we're going to go kind of not backwards, but a little bit different because a lot of students had trouble with this specific portion of our final, as well as there's like a previous skills quiz, and that's going from different forms. So how do you go from one form to the other, to the other, to the other? That's the piece that started to confuse students. So there's three different forms, but we can really break it down into two categories. Trigonometric and polar form are really easy to go back and forth to. You just kind of plug and chug, you just pick apart the pieces, and you go ahead and just convert them into their other forms. So we're actually going to start there and see what we can do. Okay, I'm going to try and do three distinct examples. One starting with polar, go to the other two. One start with trig, go to the other two. One start with Cartesian, go to the other two. Okay. So the first example that we're going to do is actually from a worksheet from a long time ago. And that was going to be 2,300 degrees. So this is in polar form. Your job is to convert into trig and Cartesian form. Trig and Cartesian form. So the first one we're going to do is actually from polar into trig form. And we start with the coordinates. We start with r and then our theta. Our r stands for our radius length, and I'll show you a visual example of what that's referring to in just a second. But once we have something in polar form, it's actually really easy to convert it into trig form. You have all the parts, you just need to write it in a different way. And so the first thing I like to do here is, I like to take this and I like to put it into two different colors, because because it helps me visualize where the pieces go. So I'm going to do 2 and then 300. Okay, some people like the color, some people don't. And then if you just take this form that you have originally, the trigonometric form, you just plug in the different pieces. So the 2 comes down, and it's going to be the coefficient out in front, the r. So instead of r, we'll write 2. And then there's a cosine component, and then a sine component. And it's just 300 degrees in both locations. So you're just kind of plugging it in like a puzzle. This is your trig form. Okay. So this color's plugging it in. I'm not saying that's not the most difficult, but if you have something in trig form or polar form, even going backwards, as long as you have a theta and the r value, you just go back and plug it into the original, whatever polar form is. So r comma theta. So that's not super hard getting it into one other form. Now the hardest part is actually going from polar into Cartesian, or trig into Cartesian, any of those pieces. And so for that, hopefully we can go through a little bit of a visual example to see what this looks like. So this is going to be polar to Cartesian. Okay. There's going to be a couple ways that we're going to actually look at this. If you have your unit circles, I would take those out right now. I'm going to refer to them, and it'd be nice for you to just see what they look like. If you don't have one, you can use your partner. See if you can look at theirs really quick. Okay, so there are two things that we're going to need in order for us to convert into Cartesian form. There's going to be two things that we need. The first thing that we're going to need to know, or we're going to need to look at, is going to be the degree measured. Okay, what is the degree? What are we looking at? What is the degree? And the reason why we want the degree is because we want to know which quadrant is our value going to be in. Okay, we're looking for like the quadrant. And then from the quadrant, we're actually going to need the points. The specific point corresponding to the angle measurement from our unit circle. The second thing we're going to use is the new radius as a scale factor for our point values. And I'm going to show you what that looks like in just a second. Okay, so what I'm going to do is spin in circles and then stand up here. So we have a very faint unit circle up here. And can somebody tell me where is 300 degrees located? bottom right. Now, is it like here, or is it here, or is it like here? Around in this spot? Okay. So I'm just going to go ahead and put a random point down there because we're essentially looking at this unit circle. Actually, I'm going to go like this. Something like that. It corresponds to 300 degrees. And can somebody tell me on your unit circle what's that point?
Sorry, root 1.
Okay. How many of you see that on your unit circle? You see it? So here, the red is going to represent your unit circle. Okay. What is the radius of a unit circle? Yeah, it's 1. A unit circle. Everything is based off of a radius of 1. But there's a problem because what is my radius now in this point?
2.
It's 2. Okay, so you're with me. So I did this with I think it was with Angel and Hector yesterday or last week. But that means that this whole circle, the radius is going to increase. That's not bad. This radius is going to increase to become a radius length of 2. And so for that, the circle that we're actually representing is not going to be here at 300 degrees. It's going to be down here at 300 degrees. And so my new radius is a value 2. It's longer. And so we need to account for that adjustment. So I'm going to pause there. Our unit circle helps us look at all of the points corresponding to every single angle that we have represented on our unit circle. I think Angel made this a long time ago. Right? Every single angle is represented by some sort of point that gives you these values. There's an x value and a y value. Now the problem is it's based on the unit radius of 1. Our new unit radius is a radius of 2. And so what we have to do is we have to account for that. So here comes the work. So here comes the work. If our value was 1 300, we have a radius of 1 and my value is at 300, my corresponding point is going to be 1/2 negative root 3 over 2. But we made an adjustment. We're still at 300 degrees, but my radius measurement is now 2. So what do I need to do to account for this change in my radius and change this value up here? Multiply it by 2. And so in this case, I'm just going to take everything up here, and I'm going to multiply it by 2. I'm going to take this, I'm going to multiply that by 2, which means my new points will be what?
1.
1 and negative root 3. And now, to see exactly what I did, I took this point, and I took each of those, and I multiplied it by 2, multiplied it by 2. Because the denominator is already 2, those 2's actually cancel out. Which means I'll have 1 and then negative root 3. We're done, right? Does that look like Cartesian form?
No.
No. And so we have to remember Cartesian form has the form of a plus bi. So now we're messed up because we're not 100% to the answer. So it's actually really easy. This first value here is going to represent our A, and the second value here is going to represent our B. The I is implied because we're talking about a complex number. So my final solution should be A plus negative root 3i. Or you can write 1 minus root 3i. And this is in Cartesian form. Shannon, you can turn off the video there. That would be one example that we throw up.